Okay, welcome everybody. Hello, my name is Filko. I work on the Grow team at DFINITY, and today I will be your host for the Blue Sky category. The Blue Sky category is the category where developers could really build anything they wanted using the internet computer, and that didn't fit some of the other categories. The judges for this session, in no particular order, are Cloud Dante from Tomahawk VC, Alexa Smith from Polychain Capital, Hitter Stu from FBG Capital, and sorry for the slides there, and Igor Lilik from Blackcomb, Tony Chang from Foresight Ventures, and that is it, our amazing judges. There's of course the real stars of today are the finalists, and the presentation order in which they will present their projects is Candb Plus, Internet Computer Services, Union, Kinnick, DTI, Candb, and Fox IC. Before we start with the presentations, let's go over the rules one more time. Each presenter has 6 minutes for their demo. Could you go to the next slide, please? After the demo, each presenter will have 3 minutes for a Q&A session with the judges. And please be mindful of the time, because once the time is up, I will cut the presentation off because we're on a tight budget. And judges, please fill out the scoring sheets that you have before the end of the last pitch. For everybody's information, this session is being recorded, but only the speakers, judges, and panelists will be visible. That's it for my part. Let's kick things off with Candb Plus. Please share your screen now and let's get started.
Hi, we are IC Hub, and the project we are presenting today is Candb Plus, a better candid UI with test cases and authentication support. First, let's talk about our initiative. When we were actively testing the contracts, we found a tool called Candid UI, a Swagger-like tool to inspect and call canisters public methods. Candid UI is the most frequently used developer tool on IC, but it misses some important features, such as user authentication and user input logging. Inspired by Candid UI and realizing that testing is a crucial part for safe contract developments, we decided to improve Candid UI by adding test cases and logging. The core feature of Candb Plus is the test case. A test case is composed of multiple canister calls. Users can edit their test case, examine the test case history, share the test case, and view the test case statistics. The second feature of Candb Plus is management. Users can follow, unfollow new canisters, edit the canister information, and manage canisters such as install, upgrade, delete, etc. The architecture of Candb Plus is fully decentralized and infinitely scalable. It consists of a registry canister that tracks all user registers, shared data canisters, private data canisters to cache the user profiles. Shared canisters are free to use, but user privacy is still fully ensured by the Internet Computer Authentication System. Private canisters are paid to use and fully controlled by the users, which are more suitable for larger teams and enterprises. Candb Plus also supports local testing and team working, meaning multiple users can work on the same test at the same time. On the roadmap, we have just released the alpha test version of Candb Plus with basic supports for creating test cases. We are still working on features like local testing, canister manager, canister monitor, and Geekspace. Once fully developed, IC Hub will become a venue where developers can test, share, talk, and debug the canisters cooperatively. With our effort, we believe smart contracts on IC will be more transparent and safer to use. Let's start our demo. First, just type hub.icp.xyz is the ICNS domain name. Once you are in this page, just use connect to IC. It will use your regular internet identity to connect. And once you are logged in, the first things you need to do are following some new canisters. So go to the canisters tab and add some new canisters to it. So the first one we're going to use is called the microblock. It is a canister we created just for testing the features on IC Hub. Let's name it microblock. And once you have followed, you can follow another canister. This one we're gonna follow is the ledger canister of the NS subnet. The one we actually used to transfer ICP in the IC network. So once you have followed the canisters, you can then go to the test cases to create a new test case. Let's create a demo test case. So just keep in mind, once you are logged in, we're gonna create a private profile, and all your data is cached there, decentralizedly on IC. So you don't have to worry about leaking your information or anything. You can also set your profile to be public so other people can check your test case. So just add more cost to the test case. Let's play around with the microblock. Just use set name follows. You can delete one here or like post. Follow, post, get name, confirm, demo text, the microblock post, just some random text will be okay. Subquery call requires int, get name does not. Let's add another call called test variant. Let's do a rectangle. You need a number here. And once you have created the test case with all the canister calls, you can just save and call. So Candb Plus will call each test case, each canister call sequentially with the parameters you input. Once you are done, you can save it to history. And in history, you can inspect each canister call with the parameters and results. You can also add more cost to it. For example, you can add a ledger call, like name and query blocks. Let's put a random block number and some length. Then you can save and call again to create another test case run. So it will run all the canister calls there still sequentially. And you can also examine all the parameters and results here. And once you are satisfied, you can save to history. And you will see test case run 2 here.
Thank you so much to the team from Candid Plus. The next one in the lineup is Internet Computer Services.
Hello, everyone. Over the past decade, we have seen the decentralized technology evolve from just being a ledger technology to smart contracts, and now we have decentralized clouds, aka the Internet Computer. Just little over 1 year, the Internet Computer itself has grown, approaching 1 trillion blocks, and already 100K smart contracts or dApps deployed. This basically verifies there is a lot of developer activity happening on the Internet Computer. But from a developer's perspective, building is easy, but hosting is agonizing. From managing multiple identities or wallets to CI/CD pipelines, creating canisters, managing multiple versions, backups, release management, all these are a lot of activities to deploy a production-ready smart contract. And to achieve this, companies spend huge amount on DevOps. I have myself witnessed this when I was working at Amazon and Microsoft. They ship great products, but not without a massive. So to achieve this, companies spend huge amount of money on DevOps, and I myself witnessed this. They ship great products, but not without a massive DevOps team. Apart from that, there is a huge learning curve for developers as well to keep up with the technology. This incurs a lot of cost to the company and can also be intimidating for developers. That's where the Internet Computer Services is born. We help build, ship, and manage dApps faster on Internet Computer. ICS provides an easy workflow for hosting and managing high-performance dApps on Internet Computer, and which is fully compatible with Web 2 and Web 3 tools and services. Once the dApp is built, ICS saves huge amount of time, money, and energy to have dApps deployed as a production-ready smart contracts on the Internet Computer. This is how a typical ICS workflow looks like. Developer can build their smart contracts in any of the technologies they like, and then they can use ICS to deploy and ship their dApps. This hardly takes a minute for the whole process. And once it is deployed, they can manage their canisters to upgrade the smart contracts or monitor them to top up with cycles at any time. All the in-house problems are solved and the solutions are streamlined with Internet Computer Services. It's time for a quick demo now. So anybody can go to internetcomputerservices.com, and we have given a single sign-on with GitHub. So developers can easily log into their Internet Computer Services dashboard, and there the developers basically get a comprehensive summary of their whole infrastructure. One of the core functionality is canister management. So developer can just come in and create a canister. What this do is internally, this talks to an ICS management canister, which is already hosted on an Internet Computer, and it facilitates creation of canister with just one click. This saves all the hassles of buying ICP from a centralized exchange to sending it to your internet identities, converting into cycles, just to provision a little smart contract there. Once the canister is created, we can basically easily monitor what is happening inside a canister. We know we automatically top up the canister with some default cycles, and then we can also install different WebAssembly modules just from UI clicks. You can either choose a file to deploy a smart contract, or you can even use a registry feature to basically pre-upload the binaries or smart contracts bundle to your own private registries and deploy it from there. Now, talking about registries, we can consider registries as Docker registries. So developers can plug in these registries in their CI/CD pipelines, and once the code is built, these registries can push the WASMs to Internet Computer Services, and these can later be used to basically install these registries inside the canister. As we can see, there are a couple of registries which are already there. Now, apart from this, we provide inbuilt monitoring as well. So if you see, every canister is basically being monitored every 2 hours just to see what was the module hash deployed, how many cycles are remaining. And if need be, developers can also top up their canisters with cycles directly from the UI in terms of in incremental counters of 1 trillion. Apart from this, developers can also explore the smart contract which is deployed by just clicking this view in a Candid UI. We have just given a Candid UI integration, and this directly explores your smart contract on the Internet Computer. So you can see all the assemblies and the methods can be easily visible from here. Now, one of the core features is marketplace here. So developers can basically come in and submit their decentralized application as well. They just have to put in their name, GitHub URLs, the version, and upload the binary here. If I can see, I can go to a particular dApp, and as a user or a customer or any other developer, I do not have to reinvent the wheel. I can just choose a smart contract or a dApp from the marketplace itself and can deploy it with just one single click. If I just deploy this dApp here, this will create a canister and deploy the smart contract accordingly. And from this marketplace detail page, I can see where the GitHub URL of the app is, who basically created it, and whatnot. Now, going forward, we plan to hugely invest in building more capabilities in Internet Computer Services. And the main feature will be pipelines. We really just want developers to connect their GitHub repositories and be worry-free. ICS will take care of building the binaries, storing them in registries, and deploying them to the canisters in the production environment. The other core features we also plan to give are NFT minting to help a lot of projects even raise money or sell their digital arts, or to create a token with few simple clicks to basically monetize on their products. And with this, ICS plan to create few of the core services which help as a building block for softwares, like simple queuing services, secret manager, password managers, or identity, which can even be used by other dApps or even in the traditional world to build softwares on top of what the developers are originally building. Now this
And the time
concludes
is
my
up.
demo, and I'll open the forum for questions now.
Thank you so much, Richie. The next one in line is Union.
So my name is Sasha, and together with my colleague Roman, we present Union project. Next slide, please. We believe almost every person has a dream project. We, as a team of software developers, have many of them. We spend a lot of time researching, designing, and prototyping different ideas. But it always comes up to the same exact question. Okay, imagine we have this project up and running, but how do we build an organization around it? How do we decentralize this organization? Next slide. And we can imagine a horizontal organization solving this issue. There is a thing for it, which is called DAO. But what about other, more traditional organizations, like restaurants, movie theaters, grocery stores, and others? We can imagine such organizations incorporating DAO into their routine. But in practice, this would mean that now there are two separate organizations. The first one, external, is a horizontal DAO where the community is. And the second one, internal, is a vertical, legal one where the whole actual project is happening. Next slide, please. So the idea of Union is to invent a new kind of digital organization where internal and external activities happen in one single space. Key features of such organizations are that these digital organizations are self-sovereign. They live by their own rules. Also, the digital organizations are subjects. They are able to interact with other web services or other digital organizations on behalf of themselves. Next slide. In Union, every organization provided with a powerful decision-making system. In order to make important decisions, which typically require a lot of confirmations from many people, there are votings. In order to make quick decisions, which are typically made by a single person, there are responsibilities or delegations. Next slide. This system is super advanced. For example, our votings are multi-choice, multi-winner, multi-round, and with premediation of proposals included. And these votings do not even use staking. Next slide. Basically, the decision-making system is also a charter of a digital organization. And this charter is configurable and extendable. You can change everything about it whenever you want. This means that such a digital organization has a dynamic organization form. You can make it into a corporation, or into an LLC, or into a cooperation, or into something completely new. Such an organization can adapt to whatever will work best for your business. Next slide. Also, each digital organization is supplied with a special history ledger that tracks all the activities this organization ever participated in. This history can be deleted or tampered with, which makes the decision-making process of your organization as transparent as it can possibly be. Next slide, please. But the most exciting thing about Union is that it requires zero integration effort for other web services. As we said earlier, digital organizations are subjects. They interact with other web services, and they do that on behalf of their own principles. So a remote web service might not even know if it's being called by an organization. From its perspective, it is just another user calling its canister methods. This means that Union is integrated with every other web service by default. In other words, Union just adds another type of user to the internet computer, an organization. But if the web service developers want to provide additional features, or at least some custom web interfaces for digital organizations, there is also a protocol for that. If you're curious about how it works, there is a demo of this protocol in our project video on DevPost. Next slide. We're developing Union because we really need it, because it will allow us to build our dream projects later and to build organizations around these projects in the way we see it. And we think that we're not the only ones who are in the same situation. As we can judge by the way people react to SNS, the IC community is in a big need in such a tool. We believe that the richer the ecosystem, the more diverse it is, the better. And we think that Union would be a great addition to it. In future, Union may become the project that will introduce IC to a wide audience of people who never tried anything crypto before, but searching for ways of making their existing traditional business more transparent, resilient, and efficient. So this is it. Next slide, please. Here's the link to our Discord. Please come ask your question. And also please see our project video on DevPost. Unfortunately, we had a technical issue, so I can't show any demo. So the submission on DevPost is our only source of info here. Okay.
Then thank you, Sasha, and let's hop on over to the next one, which is Kinnick.
Hi, this is Wyatt. I'm a serial entrepreneur and the technical founder of Kinnick. Kinnick is the world's first Web3 search engine. So what is Web3 search and what is Web3 content? Web3 content has just recently become possible with the novel application of the Internet Computer Protocol. Web3 content is any images, files, designs, assets, or text natively created and stored on blockchain. It can be served to modern web browsers and is an end-to-end consumer applications. So in the formal paradigm, you would have a front end that was on Webview and a back end that's on Web3. So you'd have DeFi that might be on a blockchain, but the front end would be on a standard centralized AWS server. Or you'd have NFT assets the same way. You'd have the contract on Ethereum and you'd have the assets serving from Webview. This has various problems, the security issues. Also, the centralized source can just turn off your app whenever they want. But now with the Internet Computer, we can have all of this on Web3, the back end and the front end, which we call Web3 content. We are Web3 maxis. We want everything to be completely on chain. Kinnick is live. You can actually go to kinnick.io and try it today. It is the world's first search engine that allows users to input text, categories, or canister IDs to discover relevant Web3 content. Web3 is great, but does have a few barriers to entry. One is a high learning curve. No code, low code, and developer tools look to assage this. People need to be able to use Web3. Secondly, it has low accessibility. Not only do they need to be able to use it, we want them to be enjoying while they're using it. So while it's NFT standards and marketplaces look to help with this. But lastly, and what we think is most importantly, is low discoverability. Currently, all Web3 products depend on a centralized Web2 search to be discovered. It doesn't matter if you create the best thing, spend the most money, if no one can find it, it's not significant. No one will use it. So we think letting Web3 become discoverable is very important. So we want to make using Web3 a no-brainer for both creators and consumers. How, you ask? We're going to make Web3 discoverable. Kinnick allows people to discover new and exciting content on Web3. How does it work? It's a little bit technical for 6 minutes, but basically what we did was scan all the canisters on the IC and then index those canisters, categories, and keywords. This means that we can see what's coming out, what's being used, and what's being deployed, but not being updated. So we have this vision from the edge of the IC-verse, and we're keen to push its expansion. So with this hackathon, what I actually wanted to do was a full-blown product market matchmaking experiment. So I started completely from scratch. There was no Twitter, nothing. After 10 days of building, we actually released the first version publicly, and we built publicly from there. And from that, we actually had a lot of traction. 1,000 followers in the first month, 10,000 unique searches week 1. And actually, the last 2 days, we had 10,000 searches just in the past 2 days running up Supernova. Let me move this out of the way. We actually have revenue. We're a 1-month-year-old startup, and we already are making money. It's basically paying for itself. And we did crowdfund NFT. This was focused on new companies coming out of the IC to spotlight their applications in our search engine. It was the fastest sellout of all time. So we have super strong traction for month number 1. So I'm actually going to do a live demo. If you go into any web browser, I hope you can see my screen still, and you type in kinnick.io, you can actually load the application. And Kinnick will pop up. We'll do an easy text search. We'll try Supernova. Everything that's on the IC that's related to Supernova will pop up in these searches. You'll see open source, sorry, if you can't see that, official, and Twitter. If you actually click on the open source tag, it will bring you to the GitHub repository. Or if you're interested just in categories, these DAO, DeFi, and games, if you actually click on one of these categories, everything on the Internet Computer that is related to these categories will pop up. So these are all the DAOs on the Internet Computer. On the right side, there is actually an advertisement. There is backend code with Ledger Canister that has an option for this. We can't show that today because we're gonna run out of time. But basically, it's a very decentralized process to get these up and running. Lastly, what we're gonna do is actually take our Canister ID and see if we can get a feedback loop and blow up Web3. Okay, it pops up and Web3 is still working. But those are the 3 ways you can search. And the last portion of it is actually the claiming your site. If you claim your site, you get an official tag, which boosts you up on SEO. So we've used these innovative methods to create a new product with 1 month KPIs to make a unicorn blush. And we believe that Web3 search is essential, not just for the internet computer blockchain, but any blockchain, and also regular users, people who are not even aware of it yet. Please vote Kinnick, and please reach out after the event if you're interested in discussing more. We're at Kinnick_app on Twitter. Thank you very much.
Thanks, Wyatt. Let's go over to the next presentation, which is from DTI.
Thank you so much. I appreciate getting to be here today. You know, when Akshay and I started the Supernova competition, we didn't really know anything about the IC. We decided to make that our mission, right? What is special? What is different about the IC compared to other blockchain technologies that we've seen in our travels? And what we found was a beating heart. The heartbeat function is a core part of the IC specification. It says that any canister can hook this to be invoked, have one function get invoked every about 700 milliseconds. And this is really cool. I mean, just compare that to other blockchains, right? Most blockchains are basically just a ledger waiting for transactions to come in from like users or bots or whatever, and then they're getting validated every 30 seconds or so. That means any given function on a smart contract is only being validated, only being run if somebody from the outside says, please run it. That makes them event handlers. But on the IC, you can make the event by having it just get invoked on that regular basis without requiring human intervention. This allows all sorts of new possibilities of bots, of agents. And we thought this was really cool. But when we got into it, we got pushback from the community that, oh, wait, you know, the heartbeat, that's really, really expensive to run because it is not an update function every 700 milliseconds. And that dates are hard to work with for casting things into the future. So we decided to make that our mission for the rest of the hackathon, and we made DTI. Decentralized time travel is the unstoppable scheduling service for the internet computer. It's currently, up on the IC. It's in production. We authenticate using Plug, and you can set up that you can have your canister, any canister, be invoked, say, every X seconds, and just by providing the canister ID and whatever the function you want it to call. You can have that run every day, every week, every month. You can set up one-time messages sometime in the future that even you can make cancelable, which allows for an interesting sort of dead man switch type effect too. And if that's the part we're trying to make it easy through a simple API in the kind of form that you're seeing here, we also try to make it affordable for the use of the DTI token, in which you can pay for those messages that you're scheduling to have run for you in the future. Right now, each DTI token pays for about 10 messages you might have go out into the future. And if I just start minting it, it'll actually connect the IC canister that I'm running this presentation from to DTI, because now I'm able to pay for it. And it's going to run a little service every 30 seconds, giving me a bit of a time check. So by having this shared service and using the token, we can bring down the cost of using this IC-specific capability by orders of magnitude. We get to use a simple interface to make the process of actually using it much, much easier. And because it's all running on the chain, it is unstoppable. Unlike like a bot or a chain link or whatever, there's no throat to choke. Now, the feedback that we've gotten back from the community has been really positive, really useful across dev post, across Discord. But the thing that has most excited us is people saying, I want to build with this and create things that were previously impossible. And the applications go across all the domains that we're talking about today at this in demo days. Like just consider, say, DeFi, right? The auction is a basic way of doing price discovery. But in order to have an auction, you need to have an auctioneer whose job it is, say, after the sealed bids come in, to decide which of them is going to win and make the transfer of the property. Or let's imagine a live auction, like going once, going twice. There needs to be a time delay right after the last bid in order to decide who's going to do that. That requires an agent whose job it is to actually making that transaction happen. That can happen on the IC because of this autonomy, whereas it couldn't happen in other blockchains. Imagine elections on date certain for governing DAOs, royalties that can pay out over time, a metaverse of agents that are interacting with each other, even when nobody's looking. Now, the number of applications keeps on going on and on as we talk to more developers, we find more ways it can be used. And that really is exciting for us because the Supernova competition isn't just like other hackathons where it's like you did a nice project, here's a pat on the back, here's a little bit of a prize. It's about the future. It's about the future of the IC that we want to create together. And there's certainly work to be done. There's technical work in terms of completing the API to make it more machine to machine, actually having the economics run so they can pay for itself as opposed to the faucet that you saw me run that's basically free right now for the hackathon. And then, of course, engaging with the community, right? To figure out what is the combination of tooling, of documentation, of scaling across subnets that will allow us to enable the future of composable, autonomous, unstoppable services, agents that can be working together to form the internet computer with DeFi.
Thank you, Ray, for that awesome presentation. Let's hop on over to Candb.
Hi, I'm Byron from CanScale. CanScale is an initiative to leverage the unique capabilities of the internet computer blockchain in order to take on the trillion-dollar cloud computing market by building a suite of scalable infrastructure tools for the internet computer. Today, I'm going to talk to you about Candb, the first truly scalable NoSQL database on the internet computer. Developers coming from existing cloud platforms like AWS and Google Cloud Platform already have experience building scalable applications. In fact, they expect ready-to-go services and databases that facilitate scaling. In the NoSQL market, the top 3 databases are MongoDB, Amazon DynamoDB, and Apache Cassandra. On the internet computer, canisters are the unit of computation and data storage, and they're bounded by a heap size limit of 4 gigabytes. Depending on the circumstances, overflowing the heap can result in application upgrade failures, or even the application canister becoming unresponsive to requests. Building out scalable storage while maintaining flexibility is complex, and many large projects on the internet computer, including internet identity, still have the majority of their application housed in a single canister due to the complexity of building an auto-scaling solution. And each of these applications will need to invest time and resources to research and develop a scalable data storage solution, custom to their application that could be spent building their application instead. These costs are then repeated across each project, slowing the progression not just of each team, but of the overall rate of development and growth of the internet computer. So I'd like to introduce to you the solution, Candb. Candb is the very first scalable NoSQL database built specifically for the internet computer. Candb is written in Motoko and has a familiar NoSQL API that compares to MongoDB and DynamoDB, allowing for scalable and performant CRUD operations by using a partition key and a sort key that allow both direct and range-sorted access to that data. Similar to Apache Cassandra, Candb is an open source library that abstracts and automates many of the complexities of building a scalable application on the internet computer, such as dealing with canister auto-scaling, cycle management, or the equivalent of gas management, and the stability and persistence of your data while rolling out upgrades to your application's fleet of hundreds, if not thousands, of canisters. Candb is composed of 3 main parts. First, we have the canister data storage partitions on the right-hand side of the diagram, which store sorted data within a canister. These storage partitions utilize Candb data structures that allow for flexible and performant operations on that data. Then we have the Candb index canister, which holds the mapping of which canister storage partitions hold which data, and is responsible for scaling out a canister storage partition when it hits its storage limits. And third, we have the Candb client, which abstracts away and coordinates the necessary communication between the index canister and the canister storage partitions, ensuring that each request makes it to the correct storage canister destination. So now I'd like to show you a demo application I built entirely on the internet computer, where I used the Reddit COVID data set with Candb to upload over 4 million comments from Reddit where COVID is mentioned, storing over 8 gigabytes of data for this application using Candb. We can use the power of Candb sort keys to query this data by top upvote score. You can see it's all sorted by top upvote score. We can also query by latest comments by subreddit. Here you see me typing in the baseball subreddit. We can filter by date. And we're using Candb's scan functionality, which is shown by the next key under the hood, to effortlessly scan and paginate through gigabytes and gigabytes of data. This is even more impressive if we now take a look at the monitoring tab, where we can see this application is composed of a fleet of 149 canisters, all partitioned by the comment date. We can also easily view which canisters have auto-scaled, as well as other metrics about the canister. And this monitoring application is all built completely using Candb. So, taking a step back to look at the big picture, Candb is the first flexible, performant big data storage for the internet computer, enabling developers to tap into the IC's massive storage potential and accelerating the next big hit games and social applications on the IC, many of which are finalists in this very competition. So what's on the horizon for Candb? Q3 deliverables are all about Candb performance testing and bringing these metrics to developers, allowing them to incorporate performance and cost expectations into their application design before they write a single line of code. Q4 will add a few much requested features by the community, capped off by launching the Candb open beta by the end of the year. If you can't wait until 2023, come alpha test Candb with me. My name is Byron Becker, and I'm looking for 10 to 20 projects with the bandwidth and desire to build massively scalable, decentralized applications on the internet computer. In just the past week, I've received interest from over 25 projects inquiring about joining the Candb Alpha, which will be starting in late July. I'm incredibly excited to say that with Candb, it is now possible for viral applications on the IC to scale to millions of users and hundreds of gigabytes of data. And I look forward to empowering each project to reach its full potential on the internet computer. Thank you very much.
Let's go to the next one. Last but not least, Fox IC.
Hi, I'm here to introduce Fox IC. Fox IC integrates MetaMask, but in IC's way. MetaMask is so hot, you just can't ignore it. It is also the #1 favorite wallet in the crypto space. However, MetaMask is not compatible with IC. So now we're thinking how to integrate it directly. So if we can sign message, interact with that, send transaction, even we can replace the node and infra with canister. Now let me show you the demo directly. Now to run this demo, you are required to install a developer build of MetaMask. And after the account creation process, you're good to go. And now we connect to Fox IC. You authorize it. And then later, the prompt to install a snap. IC Snap is a plugin that we build, integrate with MetaMask to IC. And we install that plugin, and the page refresh. And now you can see this little box. So what it does, can sign messages, confirm, and we got a signature. Now the signature is verifiable and accepted by the Internet Computer Protocol. So that means we can interact with dApps and do canister call using MetaMask directly. So what we're doing here is that we're building a IC Step plugin inside a WebAssembly sandbox inside MetaMask and interact with the dApp using the signing function and do the ledger call and canister call. However, this is not IC native, or to say, this is not IC enough. So let's come to the demo for the next part. Now we can see this button. Now this button will allow user to install and create a canister. It will be creating a smart contract wallet at the backend. Now after the creation, you can see the canister ID and the principal ID that matching the MetaMask principal ID that is here that said you are the controller and no one and nobody else can steal the money from you. And then we can accept some ICP from my NS wallet. I say 7 cents. It goes back and refresh and see how the transaction goes. Once the transaction is complete, the balance will show here. let's say how today's network goes. Well, okay, it's here. Now I can send the money back, but let me do it later. Now the interesting part is here. Now you can configure your MetaMask here. Now pop up. And if you're familiar with, the EVM compatible blockchain using MetaMask, the process will be similar. Configure your MetaMask like that. Now we just copy paste some configuration here. ICP. That's IC. That's can show balance here. So MetaMask showing the ICP balance using our own Cancer wallet. So if you remember that ICP is not compatible with MetaMask, how can we do that? Okay, let me show how the magic is done. So we backend, we have a Cancer wallet and a Cancer factory. Using that factory to create wallet and users control. And the magic happens under here that we are using a RPC simulator to accept all the query, all the post call from the MetaMask. And then we transform the data format for as IC can accept. So the whole loop and circle is complete, and we can manipulate our famous little tool. So let me transfer my money back, maybe. Then you can see the balance should be changing. Inside the MetaMask. So let me go back to the slide and wait for a second. And so what is means? What does it mean from this little tool, little project? That I think it would be a paradigm shift, because before IC, the user that controls the MetaMask as the external account of the blockchain, and after IC, user will own the canister, just own the smart contract wallet, and then you can use that wallet to send ICP or send any other cryptocurrency by borrowing the power of ECD as a threshold and integration of Bitcoin. So the faucet wallet will be upgraded to multi-chain wallets. And also we can upgrade that part into a multi-party, multi-signature wallet. And combining with identity system, it also can be upgraded with the social recovery feature. So the paradigm shifting is indicating that user can use that little tool to go to IC and enjoy the most powerful and most feature-rich features wallet in the world. So we can see user may come to IC and see the ecosystem. So let me get
sorry,
back.
but time is up.
Yeah, to here.
I do want to be fair to the other participants.
Okay. Thank you very much.
Yeah, thank you so much for that presentation.